Welcome to Agile Data Sites.
Drew here. Here's one of the biggest problems for data center operators: planning. How on God's green earth do you plan in an industry that flips on its head every 5 years? Today we'll be talking about one of the most interesting ways: computational fluid dynamics. If you have a data center and you want to add a bunch of servers, you might think that you have enough cooling to support them. You're probably right for the most part, but you're also probably going to create some sort of hotspot somewhere because airflow is insanely complicated and very difficult to predict. Airflow is governed by the Navier-Stokes equations, which are so complicated that they include one of the great unanswered questions in mathematics. You could get paid $1 million just for finding a single example of a non-smooth solution in these equations. Thankfully, we have computational models. They use algorithms based on these equations to simulate airflow. They do this by cutting the volume of the data center into millions of little chunks and then running the equations through each little chunk to see how they relate to the other adjacent little chunks. Eventually, you put all these chunks together and you find out where the airflow needs to go. Let me show you an example. Here we're using CoolSim CFD software. There are a lot of CFD packages out there, many of which do a great job, but CoolSim fits our particular needs because of how flexible it is. We can adjust CoolSim to do absolutely anything that we need, including making a CFD model the size of a fish tank, or the size of football fields. A lot of other modelers aren't this flexible. We actually use this to model individual servers in individual racks. I'll make the model here and then check back with you when it's time to compute. Okay, so here we have our 3D model. We've created floor tiles, server racks, cold aisle containment systems, and a crack unit based on real-world measurements that we've made in the field. Now we just hit the Solve button, and the model gets uploaded to the remote cloud computing facility, which does all the math to solve these crazy number of equations. If you had to compute this on your own hardware, it would take hours or even days. Now I can close the program and do some other work. So the model came back and it looks like we have a few problems with our airflow. These aren't deal breakers, we just need to make a few changes. In this case, we need to make sure that our cold aisle containment really is airtight, which will become a big deal when we start to add servers. I'll make those changes now. Now I'll send out the model and wait for the results. Let's see how it did. It looks like everything passed and we'll have good airflow. It's nice to have some confidence here before we even started trying to build. Real data centers are much more complicated than this and require more time and effort to model, but once you've done it, you can quickly add servers and make changes on the fly so that your next deployment can just be a copy and paste. As always, thanks for watching, and until next time, stay centered.